So I'd like to present MAVLink tools, or a bunch of things that are developing. Part of them are already on the MAVLink organization. Some of them we want to move to the MAVLink organization. And they are tools that we are working on for a couple of years. And I want to present today. Talking with some people, I was kind of like, okay, you should be using these tools, or I think we have a really nice solution for you. So it'd been really nice to talk about the things that we are developing to make it more popular. So who am I? As Ramon said, I'm Patrick Electric on GitHub. I'm mostly everywhere. I collaborated with KGC and maintained KGC for a couple of years. Mostly working with MAVLink tools and MAVLink solutions to empower web technologies and other things as well. I work for Blue Robotics. We empower the blue tech industry. We develop sensors, thrusters, and a bunch of other things. And these are both like the two main vehicles that we have. We have the Blue Bolt and the Blue Heavy 2. And the solutions that we create are entirely open source and try to move to the organization as much as possible. They are being used on these two vehicles. Yeah, so talk about a little bit of context, cameras, communications, and connections today. So our vehicle is a bit complex. Blue Robotics have the vehicle, but at the same time, we have third-party companies that also do their own customization of the vehicle. And that is really popular. They can have CSI cameras, IP cameras, stereo cameras. They can have a Raspberry Pi. They can have an NVIDIA. They can have an AMD computer. They can have different flight controllers, different peripherals. They can have DVL, side scans, LiDARs, and the list goes on. And for network, different kinds of network interfaces. So software-wise, this is a big problem because we need to manage and make everything work. And we need to support different cameras, different flight controllers, different peripherals. And we have all these problems are around on our vehicles. And that's what we try to fix as much as possible with robotics and software-wise. We try to empower the development of different vehicles, development of a platform that allows us to develop the vehicles that empowers third-party companies to do their own product. And in the past, we had the companion software. It was a monolithic component. It was just a way for companies in really advanced developers to figure their way around MAVProxy, MAVLink router, GStreamer, and other solutions to allow the system to run. We have it for a couple of years, and we spent 6 years just rewriting the entire thing from the ground up and using modern technologies in developing solutions. And that's what we have right now. BlueOS is the abstraction that we use to handle the vehicle. It has system information, have APIs for MAVLink access, camera management, extensions where you can integrate a specific peripheral, just install an extension and plug and play as an app, and things like that. And the solutions that I'm going to talk about today, it's mainly being used in BlueOS, but nothing's holding anyone to use it to develop their own alternatives and their own solutions. So the first one that I want to talk about is the MAVLink Camera Manager. It started in 2019, so it's 6 years old. It's a small child already. It replaced hard-coded GStreamer and FFmpeg pipelines. It provides a REST API to stream management, thumbnail generation, camera controls. Last year, we had Zenoh integration with Foxglove methods. So if you're using Foxglove to visualize your vehicle data or rerun, we have Zenoh integration. So you just need an MCAP file and you're ready to go. We have WebRTC support for web-based ground control stations. There are a lot of people that talk about web-based ground control stations in this kind of development. And we are empowering and creating a bunch of solutions to allow people to do that. And that's really nice. And of course, IP camera support, multiple different streams, and of course, automatic vehicle setup. If you have a vehicle with multiple cameras, different cameras, you can just send a pull request to the MAVLink Camera Manager, and we can just have the custom configuration for you, where you start up your vehicle and automatically configures everything if there is no default settings. And the MAVLink Camera Manager, or MCM as we call, it's on the MAVLink organization. We have hundreds, thousands of downloads of our vehicles, so it runs and it's pretty stable. We are trying to make a major stable release of the API, just to make sure that we are going to maintain this API for years. And that's like, that's every time that we create an API, we need to maintain it. So it is because we don't want to lose trust, because once you release it, you need to maintain the API. You can't break it every single time that you want it, just to be sure that other people's softwares will work. The MAVLink Camera Manager and other things that I'm going to talk about, since they are tools that need to be integrated in other people's solutions, we need to be sure that they are rock solid. You need to be sure that the APIs are stable, and you need to be sure that everything is going to work as expected. They are critical services, the camera stream, because on a submarine, it's mostly a flying camera. So the video feedback is the most important thing with the low latency, and it should always work. And we have this kind of development interface where you can see everything that is possible. Of course, in the back, it uses REST APIs to do everything. And the interface is not user-friendly at all because we use it mostly for development in our side. But nothing is holding anyone to develop their own beautiful interface around it with a really nice like behavior, with reactive systems, with video feedback, thumbnails, SDP files, and etc. And of course, something that I forgot to say, the MAVLink Camera Manager uses the MAVLink Camera Protocol, and that just works with GStreamer. So I can just run and get it ready to go to use camera streams. And the implementation is kind of all over the place because we do a lot of things, but the good thing is that it just works. We have support to USB camera, CSI, ITSP, OnVIF, and others. We have the command line interface, REST API, MAVLink, SDP, and as outputs, we have UDP, ITSP, WebRTC, thumbnail, and of course, Zenoh as well. The H.265 support was kind of finalized this year, and we have H.264, JPEG, RAW, and other formats as well. We try to avoid video transcoding as much as possible because we want a low latency on the video stream. So glass-to-glass latency on a normal USB camera, we have 120 milliseconds from WebRTC to the camera itself. And the latency introduced by the MAVLink Camera Manager is around 2 to 1 frame. So it's a couple of milliseconds introduced. And of course, depending on the technology that you use, you can decrease the latency in 3 frames and something like that if you use Zenoh as example over WebRTC from the experiments that we did. And of course, the moment we are working on video recording, audio transmission, in subtitle generation, just for RSD. And at the moment, João Antonio is the main developer. He's maintaining it as much as possible, but it would be really nice to have other people to help with it. I'm going to do all the demos in the end. So I'm going to do some live demos, and hopefully, if everything goes fine here, we should see some nice stuff. The other thing that we'd like to talk about is MAVLink to REST. Is another critical service because everything that we do is kind of web-based to have a really nice interface. It provides the abstraction of MAVLink to JSON 5. And it's serializer, deserializer technology for MAVLink. It allows just Empower Web Technologies to do their development over MAVLink, provides REST API, WebSockets. It have TypeScript definition as well. So if you want to do MAVLink to TypeScript through MAVLink to REST and just accessing MAVLink to REST APIs or message directly, you can do it. When you have a history server running, where every time that you need to access a message, you can access the information of the last message through the history. And you don't need to have live data as well. Through WebSocket, it's much better because you have live data directly from the MAVLink side, but you can use the history as well via REST API. That makes things much easier because you don't need to use raw MAVLink or some MAVLink libraries. You can use MAVLink direct from the terminal or any language, just having the JSON description of the messages. And it's also part of the MAVLink organization. We provide pre-built binaries for mostly everything from ARM v7 to macOS, Windows, Linux, different architectures of Linux. And it's a tool that we are developing for years already. It has a really simple interface. So we have live data to watch through the WebSocket. You have information of all the messages that are being received from the last time that the message was received to the frequency of the message, and some helper functions on the front end. Of course, this, as I do, is a development interface. It does not do all the magic that we want. But nothing, as I said, is holding you to develop your own solution, as we do with BlueOS. So all the data related to the MAVLink information, showing attitude, have digital twin, investigating MAVLink messages. Everything is possible through the REST API WebSocket. BlueOS was developed entirely over MAVLink to REST. And of course, nothing is holding you as well to develop a ground control station. As an example, Cockpit is open source web-based ground control station that developed from the ground up. It's used MAVLink Camera Manager and MAVLink to REST to do all the intercommunication. And a bunch of other features that I'm not going to talk about, but if you are interested in open source ground control station that we were working for years, take a look. And for MAVLink to REST, it's really simple. As I said, you can run directly on the terminal. And since it's JSON 5, you can introduce documentation directly on the JSON. So you can just add comments and do other things, send values as not a number, and etc. And you can just do a curl, and you send the MAVLink payload as a JSON, and we're ready to go. Of course, you still need to understand how MAVLink works and how the MAVLink fields operate. And this is possible through the TypeScript definition, where we have the entire documentation. And that's it. Something really important that I forgot to say is that both TypeScript generation, serialization, and deserialization is done through Rust libraries. So we don't code this abstraction at all. We maintain the Rust MAVLink library, and from the Rust MAVLink library, everything else comes almost for free. It's just a matter of us providing the abstractions for it, and it just generates. So every time that a new message comes to the MAVLink organization, we just update submodel, and everything else comes for free without needing you to deal with it somehow, because everything is Rust on the back end. And of course, you can just use WebSocket to get information real-time through via MAVLink, and you can just parse with JKey and just parse the message as you want directly from the terminal. So sometimes over having a really nice script doing your thing, you can just use WebSocket with JKey and just do the thing that you want to do. Well, besides that, there are 2 other tools that I'm developing in their working project. Hopefully, they are going to move to the MAVLink organization, but that will take a while because they are still proof of concepts. It is MAVLink to REST WebAssembly and MAVLink to REST, as I said, TypeScript. The main thing is that when developing Cockpit or ground control station, it quite depends of MAVLink to REST and MAVLink Camera Manager to run as a ground control station. And we did the bet a couple of years ago that companion computers would be more common, and they're still not that common. So we are just moving the MAVLink to REST from the vehicle side directly from the ground control station. And with that, there is directly WebAssembly support to MAVLink. So you can just stream raw MAVLink from your link, the serial link, or the Pixhawk directly to the ground control station through WebAssembly. And of course, all the message definitions are done in TypeScript, generated automatically. And you can just run it. That's a really nice thing to have when developing web technologies. And that's not only it. Just to have an idea, we have over 7,000 vehicles running BlueOS and running these solutions, and MAVLink REST, MAVLink Camera Manager, and etc. We have over 370 daily users. And something that we learned doing such thing is that we're making a new tool that's called MAVLink Server. Why this tool is important? Because we tried all the routers available, we investigate all the routers, we try to collaborate with the routers and make them better. But after a long discussion and we did a hackathon in creating a new tool called MAVLink Server. And the idea is to have a soft architecture that allows routing to be easy and to add different routing endpoints and having a single communication bus between all the routers and deal with all the use cases that we are working on. What we're working is a multi-thread friendly router. It has a modern front end in WebAssembly, so you can run the router on the server, and if you want to investigate the message, you can do it directly from the WebAssembly, from the website that is being generated. Have a bunch of data visualization. Every single number creates a chart. Every single, like everything else, creates a history. It has support to rerun in Foxglove integration. So you can visualize the MAVLink data directly from them. It has ready-to-use binaries. It uses the async token framework on the backend. And you have statistics per message and per driver. So if you want to check the latency or the jitter of a specific message, you want to see if a driver is failing or if a driver is not working as expected or the network is just having problems, we have all this information available. And also we have CLI, REST, REST API. We want to work on RLPL and also TOM configuration settings. At the moment, it have all the architecture, like everything necessary to add and remove endpoints dynamically. That's another feature. Over the need to restart the router, you just need to reconfigure the router while it's running to add and remove endpoints. And that's one of the main features when we develop it, because we don't want to restart the router every single time that an endpoint changes. And how it works. We have a couple of drivers. These drivers connect directly on the broadcast channel. And this broadcast channel allows every single driver to connect on it and propagate MAVLink messages. So you have UDP, TCP, file, serial, REST, WebSocket, Zenoh, and the idea is to progress. So if you want to have Lua scripts running, accessing directly the MAVLink message as a bus, you could as a driver. If you want to connect anything that you wish, you just connect on the broadcast channel and you're ready to go. The idea is that these drivers use a specific API. So if you take a look on a custom driver, you can create everything that you want to communicate through MAVLink, and that's it. As WebSocket, we have the MAVLink REST WebSocket, but we have a pull request open to raw MAVLink WebSocket. So just to have this raw MAVLink progressing through WebSocket to allow MAVLink REST WebAssembly to work. And as I said, we have REST API, web frontend in WebAssembly, and we want to support configuration files in live terminal configuration. So we have all these endpoints available, as I said, different endpoints running on the vehicle, and we have the interface going on BlueOS, so people can investigate if something goes wrong. Well, I'm going to do some live demos here. If everything goes as expected, I should have a low network latency with my vehicle, like my board here. And I'm going to demonstrate a little bit how everything works. So, well, this is BlueOS running here. Let me get the correct BlueOS, not the fallback. And have a live demo, like I have the digital twin. So if I move the vehicle, it's going to move around. I have all of the status here available. But if I want to take a look on the video stream, I can just go to the video setup page if the network helps. Yeah, I know. Yeah, so I'm in part mode. Part mode is pretty much advanced. I can create fake video streams and like video redirects directly from IP cameras. And I can see here that my thumbnail is being updated. It's not live video feed. And I can also open the correct not correct, but default video manager. Where is it? So many services, I get lost sometimes. Yes, it is. So here I have the entire configuration of MAVLink Camera Manager. I can configure the brightness, like contracts and everything else on the camera. I can create video streams based on every single camera. Well, as I said, I have fake source, so I can create fake source with different encodings. And I can also redirect video streams if I have IP camera around. We have the data on the right. And we also have the video pipeline of GStreamer. So this is something really important for advanced developers, because if you're creating a video pipeline, you need to understand how the video pipeline is working, every single connection that you have on the video pipeline available. And that's really handy. And of course, you can have the video stream working on a ground control station if you wish to have it. The other thing is, as I said, the MAVLink REST. So I can just open MAVLink REST here and have the live data of everything running. So if I open the attitude here, I can see the attitude updating live through WebSocket and being updated. But I can also do everything through the terminal. So I can come, let me find the terminal. So I can come here. Let's see if I can find the correct comment. Not this one. I think no. Yep. So yeah. So I have the live data coming here directly through WebSocket. It's being received through WebSocket and be filtered by JKey. And I can see the base mode bits being updated. And if you want to use the REST API, let's get it here. And change the first parameter. It's really hard to do it with a single hand. From 0 to 1, you should change the base bits to follow the vehicle's arm. And if you want to disable the vehicle, just change the parameter to 0, and you are ready to go. Oh, not done. That's invalid at all. Yeah, then change bits, and you're ready to go. Of course, if you want to have the full WebSocket experience, you can just remove nope. You can just remove JKey at all here and get not heartbeat. I want to get everything available. And let's remove this. And you have all the MAVLink data coming in JSON real time. So you can parse everything as necessary. And of course, you can always pipe this to JKey to have a beautiful interface. And you have all the MAVLink data available. So you don't need to parse MAVLink using MAVLink library. You can just use it and parse the data through Python, JavaScript, Node-RED, if you are a fan of Node-RED, and the list goes on. And for MAVLink Server, we can just take a look on it. It's available directly on, not MAVLink endpoints. You can configure the MAVLink endpoints through here, but you can have the MAVLink inspector. And let me just decrease the size here. So as I said, every single message here, or every single field has a chart. So you can see if something goes wrong with anything, with your attitude and etc. And you can have also the frequency of the message to see if the message is being received in a specific, a message being received in a specific frequency, or if you have a latency between the message being received. you can investigate everything. And of course, this comes out to the drivers. So you can investigate and see if the driver, example, I have a Zenoh driver, and I can see the number of messages per second. I can see the number of total bytes. So this is the number of bytes being transmitted. And that's it. You can also investigate things at the CPU usage of the router, how much memory the router is using, and these kind of things. And a MAVLink REST helper as well. So you can find and look for things for the message. So if you want to create your own message, let's see if you can find an attitude message here, and then you could see how it goes. You can do it here. And of course, you can send directly through here as well. So you have full control of the MAVLink message. And the message goes directly on the main MAVLink bus. And with that, let me just do a zoom. That goes directly to the MAVLink bus, so every single driver knows what's going on. Well, and the list goes on what you can do with these tools. And just to do a small demonstration, let's see if it works here. Hopefully it works. Let's wait a little bit. Yeah, so I have like live video feed here from the bottom. I should have at least, yeah, should have. And I also have live attitude data. So if I move, you can see the live attitude running. Everything working through MAVLink REST. And we are adding support directly to UDP, TCP, and other stuffs on Cockpit. And Cockpit as a standalone ground control station, we have the Electron and also the web app. And also, since it's web technologies, you can run it on like if you're doing a bolt mission and it's a really long bolt mission and your laptop doesn't have enough power, you can have an e-ink tablet to follow the vehicle. And that's a really nice thing because you can open Cockpit in an e-ink tablet and just follow the mission directly on it. And that's a really nice feature because you have hours of battery just running. Since it's running web technologies, you can run in your cell phone and everything else. And that's an advantage of using MAVLink REST, MAVLink Camera Manager, and MAVLink Server, is that empowers web technologies to just to do the development. I'm running through my hotspot on my cell phone, so the latency is kind of bad, but you can see the point that I'm doing. Well, thank you very much. I would like also to thank to all the contributors on the project because we have people maintaining REST MAVLink, MAVLink REST, MAVLink Camera Manager, MAVLink Server, and we are receiving pull requests and a bunch of people are interested on it and asking for things. A lot of people ask for things. And that's mostly it. Thank you.
Thank you. We got 1-2 minutes for questions. Anyone have any questions?
How does the MAVLink compares to like 1553 or CAN bus?
MAVLink works great, in my opinion. It's like some people have problems with MAVLink. Some people complain about MAVLink, but everybody uses MAVLink. It's like the common dialect for people to talk. So yeah, I think MAVLink, I was talking with Hamish and like there is still a long life ahead. And it's like a good protocol in bandwidth size as well. Of course, with MAVLink REST and other technologies that I'm talking about here, the bandwidth is quite high because it's serialized MAVLink to a REST API. But of course, you can use MAVLink router to send a raw MAVLink through WebSocket, and that's have a good performance.
I have a question. Are you planning to migrate some of these to the MAVLink organization?
To what?
The MAVLink organization?
The idea is to move the MAVLink server to the MAVLink organization, as we did with the MAVLink Camera Manager and MAVLink REST. The MAVLink server at the moment is like in work in progress, but once we are happy and the API gets stable, the idea is to move to the MAVLink organization.
Excellent. Any questions? All right, we got a question over there.
Yeah, so my question is about the MAVLink Camera Server and what adding like a new camera, for example, a thermal camera, looks like to that, and also what level of control you have over the GStreamer pipelines.
Let's see if I can show you, because it would be much better. So for thermal cameras, we have support, as you can see here, thermal. So I can just integrate a thermal camera directly. Let's see if I can do a zoom here. Yeah, thermal here. So I can just enable thermal, and it uses the MAVLink thermal configuration through the MAVLink Camera API. For any camera, the most important thing is that have a video for Linux support. So if the camera is a normal USB camera, it should work. If you have a stereo camera, it should also work if the stereo camera provides like encoded video support, not only point clouds and things like that. So it should run. We don't have any demo with stereo cameras, but I tried and have some experience, and it should work. There is no problem with that. And also thermal cameras as well. It should just work. The question is just to be, the video stream need to be encoded somehow, but they usually is. They are usually encoded.
And can you do things like hardware acceleration with the encoding and like bitrate limits?
The question was about video, like hardware encoding. You can. At the moment, we are not doing, because from our side, we want to have a really low latency. But we are working at the moment to support other pieces of hardware, including the NVIDIA board. And the idea is to support NVIDIA hardware encoding capabilities. The most important point for us is the low latency, and that's what we're aiming for. But as I said, nothing is holding anyone to just send a request to enable hardware encoder.
All right, I'm taking a video of the hardware. Looks so cool. Thank you, Patrick. That was pretty awesome. Please give it up for Patrick.